Yeah, I wanted to talk a little bit about secant lines, which also links us back to input and output. Let's start with input and output. So we'll just keep it simple. F of x equals 3x squared. And I really want to make sure that you're clear on the difference between these two things. This is a provided input. This is provided output. Find the input. So the important part in terms of function notation, in terms of input and output, is that the input is generally associated with x and the output is associated with y. So as we're thinking about secant lines, slopes of secant lines, we would be creating xy pairs so that we can basically find 2 points, then we can find the slope in between them. And if we wanted to, we could go even further and find the equation of the line. So for instance, if I'm asked to find the secant line on the interval 1, 2, these are inputs. This is x equals 1 to x equals 2. So I put in 1 and 2. This is my output, which is what happens when I put the number 1 and 2 into my function. Here, this is 1 squared times 3 and 2 squared times 3. So the secant line is going from 1, 3 up to 2, 12. And the slope of the secant line then would be 12 minus 3 over 2 minus 1, which is 9 over 1, which is 9. Okay, so this is just very basic kind of number crunching. We're putting numbers in, we're getting numbers out, then we're taking those pairs and we're turning them into XY coordinate pairs so that we can find the slope of the secant line. So I think that one of the problems that I saw was like f of x equals sine x. And so they were looking at the interval maybe from pi halves to pi. Now this brings up the point about the unit circle that I was making before. These values are going to come out nice in your calculator, but if we go to like pi thirds or pi fourths or something like that, you're really going to need to be able to think in terms of the unit circle. So if we're finding the secant, again, this is my input, x equals pi halves, 2x equals pi. So f of pi halves, okay, is sine pi halves. I'm thinking in terms of the unit circle. So let me just get a little circle going on here. If you're using your calculator, which is, I think, okay to check, but you really need the knowledge here to be able to do this without a calculator. Remember that the input needs to be set to radian mode, not degree mode. So pi halves is over here. This is 0, 1. Remember, sine is associated with the y value. So sine of pi halves is equal to 1. That means the input of pi halves has an output of 1 for the function sine x. And we're using this as our concept of xy so that I can create this secant slope. So then when I go to pi, I'm down to 0. And so now I'm doing change in y over change in x. That's my slope formula. So I can do 0 minus 1, pi minus pi halves. This is negative 1 over pi halves, which means it's negative 2 over pi is the exact solution. I don't know if they want the exact solution, but you should be able to provide the exact solution. And again, this is a place where if you've got weak foundational skills, these kind of things can be very hard because you're sort of, I just did pi minus pi halves in my head. Well, that's because I know that this is 2 pi halves minus pi halves. So it's 2 pi halves minus 1 pi half is 1 pi half. I did this division in my head because I'm doing negative 1 divided by pi halves, which is negative 1 over 1 times 2 over pi. And a lot of this is just computational, but if you're not doing it exactly and they need you to do it exactly, you can be sort of understanding the process, but not getting the answer right. So anyways, just want to share a little video with you to get you kind of going, thinking about these secant problems. And let me know if you need more help.